This
So,
conference will now be recorded.
so we'll start off with a very quick recapitulation because some of us was not there yesterday. Um, and so what we'll do is we'll do a very quick recap of the discussions that we did in the last class. And from there, we will move on, we'll move ahead to to talk about the ID variant, like talk about the data quality procedures in the next steps of the data quality check procedure in further details. So, in the last class, we have been talking about, we did a very quick recapitulation first of what we had done, which incorporated the three stages that we had talked about: the scope analysis, we had talked about the data extraction, the challenges associated with data extraction, and we had started our discussion on the data quality, right? So, the objective of a data quality check is to ensure that the data is of a gold standard, right? Now, when I say it's gold standard, what do I mean? Gold standard means that the variables that I'm using are highly reliable and none of the observations are missing in the data. So I do not have any missing data. I do not have any outliers. I don't have any behaviors with any abnormal behavior which may create volatility in the predictions of my model. Right. So obviously what we try to do over here is we try to create a, a control. We try to create a checklist of procedures, certain procedures which would help us ensure that the data is of a gold standard. Now, after this, then, so while we started talking about the gold standard data, right, we had also been talking about the different stages or the different controls that we are going to impose. One of them was no missing observations. The second was no unusual trend in continuous variables, and no unusual concentration in the categories of categorical variables. So these were the three broad controls that we had talked about, right? Now, while we go to talk about this, in yesterday's discussion, we had been mostly focused on the missing observation side of things, right? And we tried understanding as to why and how missing observations would be working it out, right? So how is it that this missing observation would go ahead? How is it that this trend and in so basically what are the different ways in which missing observations can arise, right? And how is it that we would do the analysis of the missing observation? So our very objective was the very summary of our discussion would be that we have to ensure that there are no missing observations. There are literally 0% missing in all key variables, which include ID variables, key date variables, limit variables, balance variables, and so on, right? So if there are missing observations in some key account level information, then they need to be extracted, they need to be backtracked to the source files, and it needs to be checked. If they are missing, then that's a grave data issue which needs to be escalated at respective organizational levels, right? Now, apart from this, the next thing that we have that we want to do over here is that how is it that we do the missing observations analysis? So this is how we do the missing observations analysis. For each variable name, we compute the month-on-month missing observations, and we look into the trend of the missing values, right? So if we see that there is some specific trend in our data, then missing observation trend in our data, then what we do is we start working around that part as well, right? So having said that, the next part that we will start working with over here is, uh, you know, like variables with 0% missing at all time points. And so over here, what we are trying to do is, after we have assessed all the variables for the missing observations, right, we will be selecting those variables who have 0% missing, right? So over here, what we have is the variables with 0% missing are those variables which has their value recorded at all time points. Now, for these variables which are not missing, which do not have any missing values, missing observations, etc., what we do is we have multiple variables. So there are different kind of variables. Now, once we have done the missing observations analysis, variables with missing observations, which cannot be explained and which cannot be treated, are removed from the data until and unless they are very critical to the models. Post that, the next thing that we need to do is that for all the missing observations, from all those variables we do not have missing observations, the variables are broadly classified under four heads, and that is the part that we'll start off our analysis with from today. So basically, the first thing is ID variables. So ID variables are unique identification variables, and we expect that there must be a 0% missing, right? So there should not be anything missing. The second set of variables that we have is the date variables. Date variables, as in variables which are not needed. So date variables are variables which are key dates like account opening date, you have as on date, you have reporting date, your dates is last delinquency, you have date of recovery, date when recovery initiated, and so on. So for ID variables and date variables, only missing observations analysis needs to be done. Because if we can ensure that there is nothing missing, that's it. We don't need to treat them any further. Apart from the fact that if there are any formatting changes or say any new ID needs to be created and all, apart from that, not major or not any further quality checks are required for this variable. So all for these two groups of variables, that is ID variables and date variables, we require that these two are just we just do the missing observations analysis. Now after that, the next thing that we have over here is the continuous variable. Now, talking about continuous variables, so what are continuous variables? Continuous variables are variables like limit variables, balance variables, EMIs. Then you have interest, you have fees, you have charges, etc. So these variables, which are amount or balances, fall under continuous variables. Age variable, age is a age, duration of a loan, amount of a loan, etc. So these are all continuous variables. Now, the continuous variables, which 0%. So first of all, for continuous variables, we do the missing observation analysis. Variables which do not have any missing observations are processed through the univariate analysis. So talking about the continuous variables, so talking about the continuous variables, so talking about continuous variables, the main objective that we have is the following. So talking about continuous variables, our objective is to assess that whether there exists a abnormal trend. So whether there exists an abnormal trend. There exists an abnormal trend. Right. So whether there exists an abnormal trend. Now the question that comes out over here is that so over here the question that comes out is that how do I identify the concept of this abnormal trend? Right. So I had shown this in, in one of the previous discussion. So let me just rephrase the thing. You know what? When banks actually do their business, right? Be it the receivables or be it the number of accounts, they grow very gradually, right? So they do not grow very exponentially or very in a non-linear fashion. They grow very at a very proportionate rate, at a very constant rate, and so on. So over here, what you have is, see, this is time, right? So this is a month-on-month basis, and over here, what we have is, say, balance or outstanding balances or receivables or receivables. Now over here, what we generally do is, let's say, so I have the receivables over here, right? Now, let's say this is a long-term average value. Now the observed receivables will be looking something like this. They will be more or less symmetrical. It may go down sometimes, come up sometimes, go down, come up, but it will be something which is similar. I mean, it will be around, it will be behaving very symmetrically about that line of mean, about the mean line. So what you get to see essentially over here is that all these lines, all the behavior of this receivables over time is very symmetric in behavior, right? So it's really very symmetric. Now, why is it symmetric? Because banks, the bookings that happen for a bank, they grow gradually. They do not, say suppose today I am booking 2 lakhs. It's not that in the next 2 months I'll be booking 6 lakhs. It doesn't grow that exponentially, right? So this month I've booked 2 lakhs. So there are 2 lakh accounts. Next month it grows to 2 lakh 10,000. Next month it will go down to, say there's some closures, right? And finally something happens, it goes down to 2 lakh 99,958. So it happens like this. So there is some ups and downs like this, but it's more or less very symmetric in nature. So your average receivables behavior, your limit booked, your number of accounts that has been booked, shows some kind of a behavior like this. So if you look into a long-term data, if you take, say, let's say 10 years of data, 10 years of data of monthly data, that's around 120 months of data, you will see, and you plot that for average receivables. Or if you go to your office and you take your portfolio reports, right, and you just plot those variables, the average receivables and the over time, or say the number of bookings over time, you'll get to see a similar trend, kind of a behavior that I have drawn in the diagram, right? So this is what it means as a symmetric behavior. Hey, hi guys. Uh, okay, so one quick note before I go back to the lecture. Like if you are unable to hear me, just check whether my mic is on mute or not. Okay, so it may happen that some call comes up or someone comes up, then I might mute myself. Right? If you see that the mic against me showing green, but still you are unable to hear me, then that's a concern. Otherwise, it's not. Okay. So as I was saying over here, so over here, banks will have a symmetric behavior, right? Now, if the banks have a symmetric behavior, so basically for average receivables and these trend lines and everything, so there will be a symmetric behavior. Now, over here, the next thing that happens is that I would be comfortable to use this variable for my model development if this kind of a behavior is observed, right? So this is the behavior. I'll just label it as a symmetric behavior. As a symmetric behavior. Clear? So over here, what we have is a symmetric behavior. Now, a variable with a symmetric behavior is acceptable. Now, the next thing that we need to talk about over here is that what if the variable does not have a symmetric behavior? What? So, in such a case, let's say I have a trend line showing something like this. Something like this. Now, this red peak that is there, red peak that is there, this that is there, is a unnatural spike. Is an unnatural spike. Is an unnatural spike. Now, variables with unnatural spikes may not be used, right? So, we either need to investigate why that spike has happened over there, or what we need to do is we need to remove the data from that analysis, right? Or we need to remove that variable from the analysis if this spike is observed for, say, for quite a multiple period of time. So, I see that okay, it has. Okay, so basically, if you see variables with such spikes, right, then what you need to do is, or what we need to do is, we need to investigate the reason behind the spike, right? So if I see, say, suddenly the average receivables have spiked up at a given point of time, right? And then again, more or less, it has returned back to its long run tendency. So why has that spike been there, right? Say I see the number in the number of bookings, I see there is a spike. Why is that spike over there? What has happened, right? So that is what is the next question. Now, can you suggest me some reasons as to why a possible spike can be observed? Say suppose I have the variable called receivables, right? I'm looking to the average receivables and the trend of the average receivables over a period of time, right? So I see a spike at a certain point of time. Why do I see that spike? Diwali bonus. Okay, so basically it's in the receivable side. So think from the perspective of the bank, Piyush, that the bank's receivables, that is the amount outstanding has spiked up, right, at a given point of time. Now, why is that spike over there? Why is the receivable spiking up? Now, we need to build up that story, and that is very important. The spending could have increased due to festive season. Yes, so what you're saying is that's correct. But if that is the case, right, that's a seasonal component, right? So I will observe the spike as a regular behavior. So as you can see some spikes over here, right? This spike, again, then this part over here. So these are all due to festive season behavior because so that's a cyclical phenomena, right? So that will be repeated again and again in the data. So I'll not call that as an abnormal or unnatural spike. So an unnatural spike is like a one-time event. So once or twice it has suddenly occurred, right? Which is not very representative of the overall behavior of the data. Now, why is that happening? Now, why is that happening? Any idea? So it's an unnatural spike that has happened.
Tanmay, it could be that
Yeah.
there could be various reasons, but one reason that comes to my
Mhm.
mind is if there is a change in the the methodology of calculating average balances, because average balances comes from the end of the period balances, and in some
Right.
banks they have a method of calculating average balances for the month. So the YTD average balances comes from the system, and the monthly average balances would be calculated within the system. So if there is a change in the methodology, we can see a spike sometimes. This is one
Okay. So
reason.
that's one part. That's one part.
Yeah,
But over here, Pradeep, there is one thing.
yeah,
When I'm talking about loan or credit card balances, and we're computing the receivables, portfolio reports, right? Portfolio reports do it with the month end balance, right?
correct,
Whereas
correct.
for modelers use a cycle end balance. That is why the modeling data will have some difference with the portfolio data, right? Around
Okay.
like 2 to 3%. That's up to
Mm-hmm.
5%. The difference is okay. Now, the
Mm-hmm.
main reason behind spike is average calculation method changes. That's okay. Now, I would not say the method of calculating the average changes because average is average. So it's total balance divided by total number of borrowers. Now, what may change over here is the balance variable which is used, right? So let's say
Mm-hmm.
there is a migration in the database, right, and the variable changes. So previously it was the balances were computed from one source, now it is computed from another source, and there is some substantial difference. That difference is reflected. But again, due to reconciliation exercises, those differences can be ruled out. Now, if that is ruled out, then what we would have is a symmetric behavior. So I mean, what we get is more or less a value which is close to the overall average behavior. Now, this happens mostly one major reason, right? If someone, say, if you think about from the perspective of an interview, right? If anyone asks you that, why do you think the spike would occur? One very critical reason is for the spike to occur is a change in the strategy.
Mm-hmm.
Change in the strategy. Say, suppose the bank does some particular strategy changes, be it due to downturns or be it due to business expansions or anything. So think about it this way. Let's say there is a bank who books up credit cards, right? Let's call it Citibank or any other bank. Now they book both relationship and non-relationship borrowers, right? So relationship borrowers are those borrowers who have who are generally maintaining a fixed deposit or demand deposit, minimum demand deposit balance with the bank, and the bank is aware of their behavior. Whereas a non-relationship borrower is a fly-by borrower who just comes up to this bank asking for a credit card. Now, obviously, like given the basic intuitions, you can say that a relationship borrower is less likely to be risky than a compared to a non-relationship borrower, right? Now, in that case, now so the bank is booking a boat, right? Now, what happens is that due to downturns and everything, the bank decides to ram down the non-relationship segment, right? So when a segment is being rammed down on the overall booking, so the overall booking will be impacted, right? So there, both, so you observe a sudden drop in the total number of bookings, and hence in the total balances that has been booked. So in such a case, this line will be going down somewhere over here, something like this. So you'll observe a major fall in the booking, right, as well as in the total number of total value of the receivables, therefore as the average receivables. So mostly changes in business strategy or management decisions create this such spikes. Also, migration of databases, or if the database changes or something like that happens, then again you can observe spikes. But due to migration exercises, spikes are observed, then they can be sorted out using reconciliation exercises.
So, Tanmay, just another example. So, suppose if the bank decides to consider, say, a staff mortgage or a staff loan, as their normal book, and they
Mm,
migrate that into the normal book, then we can see a spike
mm,
like this, right?
right. But generally, when banks are doing this staff lending, they label the product as a separate product, but at a portfolio level, it is included within the books. Like, for example, if it's a credit card portfolio, right, and there is a bank, this bank has certain staff accounts, so it will be flagged as the account will be flagged as the product will be flagged as staff, right, and it will be included in the portfolio. So basically, that always forms a part of the overall acquisition that happens. But yes, again, now if there are certain changes in the way the staff loan has been given, or changes to the limits of the staff loans, or any major changes which impacts the staff loan as a whole, then you will observe a spike. Say sudden, so let's say there is this bank who suddenly who talks about a case where, let's take a case, that case of demonetization, right? So during demonetization, if you look into the data of any bank, right, I'm very sure you will observe any kind of a behavior change in the overall portfolio. Also, certain spikes can be observed when the acquisition strategies of the bank changes, undergoes a very steep change. Say, for example, during downturns, right? In downturns, what happens is the overall number of bookings that the bank does has been reduced. So if that is done, if it works that way, then what you will see is that the changes in the business, then what you see is the number of acquisitions have gone down. They have gone terribly down during downturns, right? The bookings have been slashed. So in such a case, again, there would be a spike which will be observed. So therefore, the entire idea is that anything which creates a structural change in the over which has a structural impact on the overall behavior of the portfolio is something which creates a spike in the long run behavior of a financial variable, right? Clear up to this one? Any questions up to this? So, is this long run behavior of a variable, the symmetric behavior of a variable, and the concept of an unnatural spike? So, is this clear? Is this idea clear to us?
Yes, Sanma. Thanks.
Okay. Okay. Anything else that you would like to add on, Piyush? And Pradeep?
Yeah, just one question. So
Mhm.
in Mexico, there's a very popular product called payroll loans.
Okay.
So in that portfolio, in what I mean, what kind of circumstances can you observe a spike like this?
So I believe this is a portfolio which is which is intrinsic to the bank that you're working for, right? So
Hmm.
they have their own product specifications. So until and unless I'm aware of that specification, it's very difficult to say that, right? But I believe that's a bank intrinsic policy or a bank intrinsic product. So
Hmm.
I think it's not good to discuss on a public platform because of
Yeah.
certain,
Yeah. Okay.
yeah.
Okay.
So we can discuss that offline.
Perfect. Yeah. Thanks.
Okay, sure, sure. So, having said that, just remember one thing that spikes, if you the more number of spikes you observe in the behavior of the variables, implies a more volatile portfolio, right? So, the most stable a portfolio is, the more stable an acquisition is. No matter how complex the structure of the portfolio can be, the variables would not be showing much of a spikes, because if you see sudden abnormal up spikes or down spikes, what does it mean? It means that the behavior of the bank is not being consistent throughout, right? So that is something that we need to understand while we are working with the data. So we want to remove all kind of volatile aspects for this for any bank product, right? Okay. So this is precisely what we have. Now the question is that for a given continuous variable, how is the spike identified? Now, before we identify the spike, right, we need to understand how is the symmetric behavior identified. Just give me a moment. Just give me a moment. This is the problem with Scribbler at times. Scribbler tends to hang up. Harish, any question up to this point? Just give me a minute, huh? Just let it load. Thank you, Harish. Okay. Okay. So over here, the first thing that we need to do is we need to understand how is it that this symmetric behavior can be defined. Okay. So how is it that the symmetric behavior can be different? Now, talking about the symmetric behavior of the variable. Okay, so the first question that comes out is that how do we identify these spikes, right? To identify these spikes, first of all, we need to understand, we need to describe how we can represent the symmetric behavior of a variable. Now, obviously, a symmetric behavior is represented using a symmetric distribution, which is our very famous normal distribution, right? It's normal distribution. Normal distribution. So the question that comes out over here is that what is this normal distribution? Now, normal distribution is actually the name of normal distribution is not actually normal distribution. It's called the Gaussian distribution, but it generally has been because we all have believed that in the long run the behavior of variable is symmetric in nature. We call this a simple normal distribution, right? Now, talking about normal distribution. So let's just mathematically first write the normal distribution. So the function looks like something like this: 1 by pi sigma e to the power of half x minus mu pi sigma whole square. Right. So this is how a normal distribution looks like. This is a mathematical form. Now the most interesting part over here in this definition of normal distribution is this part. You see that whatever the difference is, it is squared, right? So therefore, this function or this mathematical function is an even function. So even if you put f of x, if you put f of x, the value, I mean, if you put x, the probability that you get is equal to the probability f of x, f of minus x. So if you write, say, probability of getting 2.5 is that is the same as the probability of getting minus 2.5, right? So that's why this function is called an even function. So let's just let me try to draw this function with this particular property in place, right? So let's say, so let's take this side as well. So this side, it is 0, right? So over here, let's say this is the probability of 1. This is the probability of minus 1. Now over here, if you think about it, the probability is this. right? So getting the probability of minus 2, and this is the probability of getting 2. So this is something like this, right? So basically, the distribution that generally works out over here is, so if I graphically draw the distribution, so the distribution graphically looks something like this. So you have 0, so you have x, and over here you have fx. So the distribution looks something like this. So if you actually split this distribution in between, if you actually split the distribution in between, what you will get is two things. You will get two things. Number one, you will get so what you will see is this left hand side, this right hand side. So the right hand side and the left hand side are mirror images of each other. And this shows that the distribution is absolutely symmetric in nature, right? So the value that it has over here and the value that is over here is more or less symmetric in nature. So what does this symmetric behavior talk about? What does the symmetric distribution talk about? A symmetric distribution essentially forecloses the occurrence of outliers. It forecloses the occurrence of outliers. Occurrence of outliers. It forecloses the occurrence of the outliers, right? Outliers, or what we were saying is an unnatural spike. So an outlier is nothing but it's an unnatural spike among the other variables, among the other observations in the data. So this outlier is an unnatural spike. That is the unnatural spike that we are talking about over here, right? So, so if I get any values, so if I have any variable values, right, which is lying beyond the limits of the normal distribution, then I'll say that that's an unnatural spike, right? So is this logic clear? So normal distribution has limits, right? So within those, if there are values which lies outside that limits, I'll say it's an unnatural spike. Clear? Is this point clear to us? Just try to understand this logic. Okay, so there should not be any problem. Okay. Great. So now the question that comes out is that how do we try to identify that what is the limit beyond which if a value lies will be treated as an unnatural spike. So what is that limit? How do I identify the limits? So there is some important characteristics of normal distribution. Right? So let me highlight that first. So let's say, okay, and this is your fx. Okay, so this is your normal distribution. Now there are certain characteristics of normal distributions. One major characteristic of normal distribution is that yes, the mean equals to median equal to the mode, right? So this is the mean is itself the middle point of the distribution. So it means that median values or the middlemost values are more likely to operate over here relative to the extreme values, right? So now it says that now the parameters that is used to define a normal distribution is the mean and the variance or the standard deviation. It says that in a normal distribution, nearly 66.67% of the observations lie within percent lie within mu plus minus sigma. So this will lie between mu plus minus sigma. So within mu plus minus sigma, right, mu plus minus 1 sigma, 66.67% of the observations in the dataset lies. So basically, if I say that receivables is symmetrically distributed, means that if I create the list of the unique values of receivables, then 66.67% of those values will lie between mu plus minus 1 sigma, right? So this is mu. So mu plus minus 1 sigma. So this is your mu plus minus 1 sigma. This is plus 1 sigma. This is mu minus 1 sigma, right? And this interval, or this within this interval, we see that 66.67% of the distribution's value would lie, right? Now, the next part that we have over here is it says that 95 99.5% of the values, 5% lies between mu plus minus 2 sigma, right? So what it says is that, see, lower the sigma is, right? So that means the lower would be this particular region, spread of this region, right? So the entire idea is to say that the distribution should be more. It says that if it is a symmetric distribution, the spread of the values is very low, right? So over here, this is the next part. It says that within plus minus 2 sigma, right? So this is precisely what the mu plus minus 2 sigma interval is. So it says the 95.5% of the value lies within this interval mu plus minus 2 sigma, right? So this is your minus 2 sigma and this is your plus 2 sigma, right? And it also says that 99.97, 99.9% of the values lies within mu plus minus 3 sigma. So this is the ultimate limit of the normal distribution, right? So the values are lying within this interval, then it is more or less symmetric in nature. But so that means mu plus minus, so 99.9% of the observation lies within mu plus minus 3 sigma. It means that the value which lies outside this interval, outside this interval is your outlier. Or if you have a value which is lying outside this plus minus 3 sigma interval, then that is your unnatural spike, right? So this is the concept that we would use in order to assess the unnatural spikes in the continuous variables. Clear? Any questions, any queries up to this point? Just see this description, just see the discussion. Then I'll take it up from there. I'm putting myself on mute. If you require anything, you want to ask me anything, I'll unmute myself and I'll answer. But for the timing, I'm going into mute. Just go through it and let me. Just take a couple of minutes time, go through this, try to understand. Then let me know. And then we'll take it up from there. Okay, so Mrinmay has a question over here that to explain the mathematical function of normal distribution. You need not bother much about the mathematical function, right? But still, I just give you a basic idea. So over here, see, I'm trying to define a symmetric function, right? Now, a symmetric function is a function where if I split it from in between, it will give me the similar image on the left hand side as it gives me on the right hand side, right? So that is where this e to the power of minus half x minus mu by sigma whole square comes into play. So if it's whole square, right? So it's a squared value, right? So if it's a squared value, what happens? Now, if it's a squared value, then here, so if it's a squared value, then the negative values, if I put minus x or I put x, I'll get the same probability, right? So it gives me an idea of symmetricity over here. It gives me an idea of an even function. So the most important and interesting part over here is the whole squared part. Because it's whole squared, the probability of getting x is equal to the probability of getting minus x, right? So therefore, that represents a symmetric distribution. So is this logic of identifying the spikes, asymmetric spikes, clear to us? So we first identify a symmetric distribution, the limits to the symmetric distribution. Whatever lies outside that limit is asymmetric, or that's an abnormal spike. Because if in long run behavior, the symmetric in a long run, the symmetric variable would it generally represents or reflects overall symmetric behavior. When anything lies outside that, then that's an asymmetric behavior. Clear? Good. So shall we move on? Now before we move on, we need to introduce another concept. Let's say, how do I compare? Because over here, the variable values will be on month basis, right? So on a month on month basis, you get to see the the z scores, the distributions, and everything. So you'll be comparing them, right? So I need to compare the values, whether it lies within plus minus 1 sigma, 2 sigma, 3 sigma, whatever, and to compare the values across different months, right? Because say if I'm talking about receivables, I have a trend of the value, the receivable over a period of time. So I need to compare the receivable values across multiple periods of time. Now, so that is where I need to create a benchmark or I need to create a common platform for comparing the values. And that is where we come to the concept of a standardization. What I want to do is I want to standardize my normal variance. Right? So that is where I come to the part of standardization. That is where I come to the part of standardization. And for standardization, a very useful concept is called the standard normal variate. The standard normal variate is a very useful function to standardize values originating from a more or less symmetric distribution or a set of values which are more or less symmetrically distributed. So that is called standard normal variate. So our next task is to understand the concept of a standard normal variate. And then we will weave the story together. We will weave all the plots of the story together and see how an unusual trend can be identified. Right? So let's talk about standard normal variate. So talking about standard normal variable, let's say that x is a variable which follows a normal distribution with mean mu and variance sigma square, right? So with mean mu and variance sigma square. Now from this x, right, I can compute a value, a z value, z, which becomes x minus mu by sigma. So z, what z does is z tries to assess the deviation. So it tries to assess the deviation of x from the mean value divided by or relative to the. So in a Z statistic or in a standard normal variant, what they do is you have the Z statistic, right? So then you have X. So what you are trying to do over here is you are trying to identify the deviation of X from the mean behavior relative to the overall behavior or the overall deviation in the values. Right? So this is called a standardization exercise. Now, how? Why is it called a standardization exercise? Let's see that. Okay. So this standard normal variant Z. So if X follows a normal distribution with mean mu and variance sigma square, right? X follows normal distribution with mean mu variance sigma square, then the Z statistic is defined as X minus mu by sigma by sigma. And Z follows a normal distribution with mean 0 and variance 1, right? So it follows, so Z follows a distribution of uh, Z equals to X minus mu by sigma, right? So Z follows a normal distribution with a mean 0 and a variance 1, right? Now, if Z is following this, so what is Z actually? Why is this called standard normal distribution? Why standardization? And so on all these fuss. Why create all these fuss? When because the Z statistic helps us compare between multiple X values, help us compare across multiple values. Across multiple values, right? So now the next thing that we are trying to do over here is as follows. Let's say that X is a value which is lying within, say X0, which is lying between mu, or which is mu plus minus, say 1 sigma, right? There is another value X1 which is mu plus minus 2 sigma. So now let us have a look into it like this. X0 minus mu by sigma is equal to 1. Similarly, x0 minus, sorry, x1 mu by sigma is equal to, sorry, 0 minus mu x1 minus. This is plus minus 1. This is plus minus 2. So now, once I have done this adjustment, right, now I can compare. So this is, let this be z0, and this let be z1. So what I can clearly say is that z1 has a greater dispersion from the mean compared to z0. So now I can actually compare between the two values because I've reduced them to the same scale, right? Now if I have a value, if I have a receivables value which is having a set statistic plus minus 2, then I know that that value has a greater dispersion from the mean value, right? So therefore, so this kind of a framework, this framework would help us. So this particular Z statistic, the way we have the Z statistic over here, so this helps us reduce the variable values to a particular platform. Reduce the variable values to a platform, to a common comparison platform. Comparison platform. Now, when we have reduced this to a common platform, right? So the next thing that we get to see over here is the following: that when I have done this exercise, right? So I have reduced this variable to a common platform. Then what I can clearly see is that yes, this variable is working. This variable is actually working fine, right? Because so over here I can now compare between two values, the which one has a greater dispersion and which one doesn't. So I can say that z1 is at a greater distance from the mean value compared to z0. So this is where the role of z statistic comes into play. So is this idea of the z stat clear? So is this part clear to us? So now, how do I implement this to identify an abnormal trend in one of my continuous variable? So what I'll do is I'll take up the value of the variable at one point of time. Let's say I'm looking into the average values of the receivables. Now I'll say that a variable is symmetrically behaved if its key statistical moments like mean, variance, maximum, minimum is also symmetrically behaved over the entire time period. So what I'll do is I'll take this up. I'll take up a point of time, right? Now, once I have taken that, once I have updated that point of time, right? So I'll compute the z statistic for this. I'll compute the z statistics for each of these points of time, right? And then I'll see whether any of these average receivables are exceeding the z statistic of any of these is exceeding 3 or not. Now, if it exceeds 3, then I'll flag it as a red trigger. If it is less than 3, I'll flag it as a green trigger. Because within plus minus 3, what we'll do is we'll ensure that the spike is not very severe. So if it is within plus minus 3, if all the values of the variable lies up to within plus minus 3, I know that yes, this variable is symmetrically behaved. Whereas if there are values which is lying outside plus minus 3, then I know that there is certain problems with that variable. So there is a lack of symmetricity in the behavior of the data. So over here, our logic will be to take up an average receivables at a given point of time, compute its Z statistic, right, and check whether it is less than equal to 3 or not. So up to 3, right, I'll flag it as green, right, because if Z is less than equal to 3, it means that Z is lying within the interval of mu plus minus 3, right? Now, if mod of Z is greater than 3, I'll flag it as red. Right. So over here Z is less than equal to 3 and Z is greater than 3. Right. So if I see that the descriptive, so what we do is for each of the variables we compute the descriptive statistics on a month-on-month basis. For each of the descriptive statistics, that is maximum, average, maximum, minimum, we look into the long run trend behavior of all the descriptive measures, and using this logic of that statistic we flag it as green or red. So if z is less than equal to 3, it is green, else it is red. So if any of the trigger turns out to be red, if any of the trigger turns out to be red, then we know that there is an unnatural spike in the behavior of the data. Right? So there is an unnatural spike in the behavior of the data. So this is what the overall logic is. I just show you how the final report would look like. So we will be working on that report. So let us say that utilization is a variable, right? Okay, let me just go to this case. So I have the variable for cash advance, right? So cash advance is a variable. It's a continuous variable, and I have information on this variable for 6 months, ranging from 2015-01 to 2015-06, right? Now, for this cash advance, what I have done is I have computed multiple descriptive measures. I've computed the mean, standard deviation, maximum, minimum, percentiles, right? And I have computed these descriptive measures on a month-on-month basis, right? After this, now, so this is, if I plot this, this is the value, right? Now, what I also need to do is I need to find the long run mean. So if I plot this, so let's have a quick look. What I do is just let me plot this one. Let's say I'll go to this. This is the mean, right? And I'll plot this. So what you can see that this is what the behavior of the variable is, right? Now I also have a long run mean that needs to be plotted. One second. Remove this. So remove. What I'll do is I'll fit a linear trend line. Okay. Array, just a minute. So this is what the trend is, right? Now I need to have a long run trend over here as well, right? So I need to know what is the long run trend. So I'll do a add a trend line. I'll add a linear trend line. Right. So now when I'm adding this linear trend line, you can see that all the values are more or less around this, right? So similarly, if I had plotted the standard deviation also, similarly, you would get a long, so basically plot a long-term trend line to see whether how is the data points behaving about the trend line. Now, not only me, I am doing it for all the descriptive measure, standard deviation, maximum, minimum. Now, all I want to know is that is there any abnormal behavior involved in any of the descriptive measures of this variable? Now, I need to compare all these. So it has from 2831, it has gone down to 2765. Now, how? Major of fall is this. Again, it has increased. So how major and increase is this? So to do that, what I have done is I have computed the Z statistic of each of these. So relative to the long-term mean, I've computed the Z statistic with the relative long-term mean and the standard deviation over here. So if you go to this, it is D10. So that's this value minus the mean divided the standard deviation is my Z statistic. It's my Z stat, right? So I've done it for all the months. Now, once it is being converted to the Z, it's unit free and it's on a common measurement scale, right? And then what I have done is I have looked across all the whether there is any red trigger coming across in any of these descriptive measures or not. So for cash advance, you can see that for all the descriptive measures, it is green, which is the color. So I can say that there is no abnormal movement in, or there has been no abnormal spike in any of the descriptive measures related to cash advance. Therefore, cash advance as a variable does not exhibit any unnatural behavior, right? And hence can be used for the model development. So this is the exercise that we do for all the continuous variables. Ideally, we would expect that none of the descriptive measures must exhibit any unnatural trained behavior in terms of any of the descriptive measures, right? But in real-time data, we do get that. Then we need to analyze and we need to assess whether the variable should be put through the model variable selection stage or not, right? So is this analysis clear to us?
Yes, Tanmay.
Okay, great. Uh, Anshul, Harish, Mrinmoy, Piyush, everyone. Is this clear?
Yes,
Great, great.
yes, yes,
So,
Tanmay. Yeah.
okay, thank you. So, like this, we also do for the frequency distribution test also. Right, right. So we do a computational Z stat for all the values, for all the descriptive measures over a period of time and check whether there is a red trigger or not. So similarly, we do a similar exercise of frequency distribution also. So for each category, we compute the frequency counts, and then we check whether there is any discrepancy or not. So is there any abnormal concentration happening in any one of the categories or not? The concept remains the same. So we you compute the Z stat, and the Z stat is greater than 3, it's red. If it's less than 3, it's green. Right, so this provides, if you look into this also acts as a very good control to understand whether whether the data that we are using is a gold standard data, right? So this with this we come to the end of the data quality check exercise. So now once you have done this exercise, you can see that you now have a data set which is free of missing observation and which is free of any abnormal behavior in the variables. Therefore, this is precisely, so this is what the function, so this is at the end of this, you have a proper data quality exercise, right? So with this, we come to the end of the data quality check exercise. Now, the variables which pass through this data quality check exercise proceeds to the next stage. And the next stage is the variable selection. The next part that we have over here is the variable selection. variable selection. So now the next part that we come to is the part where talk about variable selection. So variables which are more
Uh,
or less. So now the variable, yeah. Tell me.
yeah, so Tanmay, just a question here. So when
Mhm,
we find that in a Z statistics, few of the variables have this spikes in our data which are lying out of
mhm,
3 sigma. So we just
mhm.
exclude those, or we just do some more
No, it
analysis
again
on them.
depends on the criticality of the variable. If the variable is not a so critical variable, then what you do is you just remove that. However, if the variable is a critical variable and you get a spike, then that needs to be investigated. Why the spike is there? Now, if you cannot do anything about the spike, you have to work with that spike. Now, if you see that the variable has been repeatedly been volatile, then that's something which is under question, right? But mostly for these variables, if they are correctly, if they do not have any missing observation, if they have been correctly prepared, then you should not get volatile picture in the variable,
Okay.
right?
So anyhow, we have so it again depends whether we have to treat that spike.
Yeah, so that is totally dependent on the nature of the data, on the nature of the variable, everything. Now, it may be say the spikes are concentrated in 2 months, say from 2006, June and July, you get most of the red spikes, right? You know that, then you know that these 2 months ka data is something which is not very reliable. So you just, what you do is you just drop those 2 months of data, you start from August 2008, and then you take your data period. So so these reports will actually give you an idea about whether a variable is behaving volatile throughout, or is it that the variable has behaved in a volatile manner in some concentrated months or not, right? And then you can take your decisions accordingly. So there is no fixed treatment as such, no like no scheduled treatments, but it totally depends on the type of the variable, the time when it has been missing, the pattern through which it has been missing. So that is where it comes.
Okay. So when if we say we have to treat that outlier, if we have to treat that spike, so the treatment
Mhm.
is just removing that from the data set, or we
That's one of the
what?
possible treatments. That one of the possible treatments. Otherwise,
Okay.
uh, so if you feel you don't need to treat it, there can be missing outlier, capping and flooring, etc. Like we can do using the box plot method and the percentile method. Then capping and flooring can be done depending on the nature where and the rate spike and why is it actually occurring. So depending on that, that particular thing can be done.
So in real practical scenario, if we say we are
See,
developing a
most
parser
of the
model.
cases, if the spike does not occur in a very critical variable, what I do is I remove the variable. And for mostly for at a bank level, the banks which maintain the data properly, like they have a certain level of sophistication with the data infrastructure, right? So in such a case, it does not become a big challenge because the key variables do not often highlight the the red triggers. It may happen that covariates reflect such red triggers, then those covariates are dropped and then they are recreated again afresh. So in that case, most of the problems get solved. However, if the variables that we want to use are not the critical variables which show the red triggers, we just drop them. However, if it's the key variables, then again you have to do a social target mapping, go back and check why that is actually arising. Has it been because of any strategy changes or something? If it has been because of certain strategy changes, you know that you cannot do anything. You have to keep it within the data and work with it because strategy change has been just one time. Now, if it has been very volatile, then you need to identify that whether has it been volatile throughout, and if it's volatile throughout, has it been volatile because of any specific segments, and then you will investigate that. And after all, if you cannot do anything, can't find any dose, the last option is to do a statistical imputation. I mean, personally, I do not support using much of outlier treatments and statistical imputations just because of the fact that it leads to a lot of information loss,
Fine, fine.
right? Okay, great. So after this, the next part that we start off with is so the next stage of a variable, of a scorecard development is variable selection, where you are trying to select now all those variables that now you have has passed the variable exclusion test. So these are all relevant variables. These are variables which are present throughout the time period over which you are using your data. These variables which are present throughout the time period do not have any missing observations and they do not have any hey hi hi guys. So variables, so as I was saying, now the next stage is variable selection, right? So in variable selection, what we are trying to do is we are trying to select those variables. Now the variables that we have with us are those which are relevant for risk modeling, credit risk variables which have been present throughout the vintage over which we are using the data. Third is the variable selection. Third is these variables do not have any missing observations, and fourth is that these variables do not have any abnormal trend in their behavior. Now, characteristically, they are correct, they are proper. Now, what we need to understand is we need to understand these variables from their predictive capacity, right? So, that is where we are bringing in the variable selection phase, right? And in the variable selection phase, all I need to assess is the discriminatory capacity of the variable. I need to assess the discriminatory capacity of the variable. Discriminatory capacity of a variable. Right? So that is the next part. So the first step was the scope or the gap analysis, which helps us identify the scope for developing the scorecard. The second stage is that of identifying the independent and the dependent variables, right? The third stage is that of where we are identifying our business problem and the key covariates and key factors which can impact the dependent variable. The next stage is data extraction, where we identify the where we are extracting the relevant data, right? What are the possible challenges of data extraction? That is what we have seen. We have talked about archiving issues. We have talked about zipping, unzipping issues of files. We have talked about challenges associated with database changes, right? So after that comes the next part of data quality checks, where we have talked about variable exclusions, observation exclusions. We have talked about Uh, the first occurrence, last occurrence analysis we have talked about, the missing observations analysis we have talked about, the univariate analysis, and finally we have talked about the frequency distribution analysis. Right. So after this, what follows is your variable selection procedure, where we try to assess which are the appropriate variables that must enter into the model for development purposes, and that is where the concept of variable selection comes into play. Right. So this is precisely the broad framework. Right. So while talking about data quality checks, just a refresher, we have talked about missing observations. We have talked about the different reasons as to why missing observations can arise. We have talked about the different types of variables, which are ID, date, continuous, categorical variables. And what we have done is we have identified the discriminator. We have identified the way to capture the unnatural trend behavior of the variables. Right. So this is precisely what the framework is. Now the next part that we talk about is variable selection. So let's do something. Let's stop here for the day. Let's start variable selection afresh next week. So we'll talk about variable selection next Saturday, and on Sunday we'll talk more about model development validation. So which will complete the discussion on the scorecard framework, after which we'll start off developing an application, hands-on developing application scorecards.
Sure. Thanks, Donna.
Thank you. And the workshop on IFRS 9 begins today at 11:30. Thank you, guys.